So this is basically example 1. So the example math in this one, we have two particles, particle A and B. So mass of the first particle is 0.4. This is particle A. It's already mentioned. Particle A lies on a rough horizontal table and all. So the mass of the first particle is 0.8. We have two particles, particle A and particle B. So mass are 0.4 and 0.8. So if this is 0.4, so weight will be 0.4 g. If that's 0.8, mass is 0.8, so weight is 0.8 g. So particle A lies on a rough horizontal table, so we need to consider the frictional force. The table and is 4.5 from a smooth pulley. So distance between particle A and B and the pulley is 4.5. Next, the string passes over the pulley. B hangs freely with the string taut 0.5 meter above the ground level. Okay, so if this is the ground level, in that case height of this particle B is 0.5. So B is 0.5 meter above the ground level. Okay, so B is 0.5 meter above the ground level, and now I will just include the forces here. Like the forces are tension and weight. Like I have already included weight. So for B, the tension is vertically upward, as in away from the body, and for particle A, since it's horizontal, the tension is towards right because it has to act away from the body. Besides when you just remove this, the system was initially at rest. Okay, so when you remove this system, like release the system, B will move downward and A will move towards right. It's pretty much obvious, like A is not gonna go backward, right? So B for its weight will move downward and A will move towards right. And you can also check the later portion of the question where it's mentioned that B to reach the ground. It means B is going downward. So by default A will be moving towards right. So this is the it's already mentioned coefficient of friction is 0.2. It means value of mu is given. Value of mu is 0.2. Okay, so value of mu is 0.2. So I will just consider the direction of motion as positive and then write the equation here. Okay, so for particle B, let me start with particle B. So for particle B, I will take downward as positive. So weight will be, if you apply F equals ma, so this weight will be positive. This weight will be positive and tension will be negative because it's acting upward, equals ma. M is 0.8, A is unknown. We need to find the value for A. So from here you will get the equation of the tension. Like I always subject tension from both the equation and then just equate them to get the value for A. So 0.8 G minus 0.8 A. This is my first equation. For the second particle, it's moving towards right, so I will take right side as positive. So tension will be positive. At the left side, since A is moving towards right, frictional force will act towards left, right? So frictional force is mu r. Frictional force is mu r, so mu r then equals ma. So we need to find the value for mu and r. Mu is already given, it is 0.2. And r is the normal reaction force. Since the particle has a contact with the table, so there will be a normal reaction force acting perpendicular to this plane. So if you take the free body diagram for particle A, and if you consider the vertical direction, there is no motion in this direction, right? So it means upward equals downward. So from here you will get the reaction value. So if I substitute this in the equation, it's 0.4 G. equals ma. Mass is 0.4, a is unknown, so I will like subject t, but let me just simplify a little bit. So 0.4 into 0.2, so this will give us 0.08 g. So now I can just subject tension from this equation. So it will be like 0.4a, wait a minute, wait, it will be 0.08 g plus 0.4a. okay, so this is my second equation. So I'm almost done. Like I have included all the forces and then just form the equation of motion. Then solving this two equation will give you the value for tension and acceleration. We need to find the acceleration. Okay, we do not need tension in this case. So if you just equate this equation, we will get 0.8 g 0.8 a equals the second equation. So simplifying this, if you just keep this thing at the left side, so you will get 0.72 g, and at the right side if you shift this thing, it will be like plus 0.8. so 0.4 plus 0.8, you will get 1.2 a. So if you just subject a, if you divide this, you will get 0.6 g. This is your answer. If you just take convert this into decimal, you will get 5.88 meter per second square. So that's your acceleration. So this is example 1, and we are done with part A, where we calculated the acceleration. And for part B, we need to find the time taken for B to reach the ground. Okay, so B is actually moving in this vertical direction. B, from this point, B will reach the ground. So we need to find the time taken for B to reach this point. So this is the journey of B. They started at rest. It's already mentioned. They started at rest, so it means u is 0 for particle B. I'm working with particle B. So B, initial velocity of B is 0. Acceleration is this one, so 5.88, and distance of B, like height of B above the ground, it's already given 0.5. So using this 3 information, we can actually find the time taken for B to reach this ground, right? Reach the ground level. So distance equals ut plus half at square. That's the formula I'm using. So since u is 0, this portion will be 0. So 0.5 equals half a is 5.88 t square. So if you solve this, you will get t equals 0.412 second. Okay, so for this one, you just need to include all the forces here. Particle A and B of mass 5 and 3 connected by a string. Particle A is on a rough horizontal table. It means we have frictional force here. B hangs freely, coefficient is given, mu. Acceleration and tension we need to find. Okay, fine. A is here. That's A, that's B. So this is 0.5 g. Sorry, 5g. So mass of A is 5. It's already given. So 5g, and B is 3g. Okay, so B is 3g. So tension is upward, and for this one, tension will be towards right. So I will just form 2 equation. So in this situation, when you just release the system from rest, B falls down, A goes towards right. So for B, I'm taking downward as positive. So 3G minus tension equals to 3A. And for this one, it's tension, right, like downward is positive. Tension minus frictional force. Frictional force is mu R. Mu is given. R is, like I said, we have a resistive force here. So if you just equate this upward and downward forces, because there is no movement in y direction, it is just moving in horizontal direction towards right, so we can assume that it is balanced in upward and downward. It's balanced, no resultant force. So R equals 5G. Equals 5A. So if you just subject T, it's 2.5 G plus 5A. So this is equation 1, that's equation 2. So if I just equate them and solve, I will get the value for A. If you substitute A into the given equation, then eventually you will get the value for tension. So that's part A and part B. So this is almost similar to the one I have solved, like this example number 1. So once you get the value for acceleration and tension, so we are done with part A and B, but then we have to find the magnitude of the force exerted on the pulley by the string. So this is a new question, like you need to find the force on the pulley. So to calculate the force on the pulley, you just use this formula. Whenever we need to calculate the force on the pulley, like so far we are dealing with the motion for the particles only. Okay, we are not even considering anything related to the pulley. But the thing is, if two particles are here, so pulley will feel a force in this direction, right? In this situation, we have tension, so that's why pulley will feel a resultant force. Pulley will feel a resultant force. So we need to calculate the magnitude of this force. So for this one, the formula is root over t square plus 2t square cos theta. You can actually simplify this thing to if you add them up, but I kept it in this format so that it's easier for you to remember. Like I use cosine rule, a square b square minus 2ab cos theta, right? So instead of minus, it's just plus, and the a and b are the tension. That's how I actually remember this formula. So I didn't actually simplify this thing and kept it in this way. T square 2t square cos theta. So the thing is, tension, we do not have any confusion with this one, because tension is fixed. We calculated tension, right? So tension is fixed, so you substitute the value of tension. Like the pulley is feeling a force because of the tension, right? So like if for particle A and B, tension is towards upward, it means the pulley, if we draw the free body diagram for pulley, the tension will be downward, away from the body. So the thing is, pulley will feel a force, and we need to calculate that magnitude of the force. So you substitute the value of tension. So tension is okay, we are done with this. But what about the theta? So the theta is just the angle between the two strings. That's it. Okay, the angle between the two strings. So if we consider this situation which we are dealing today, like in for this setup, if this is one string, that's another string, the angle is 90. So for this setup, you will use theta as 90. For this setup, these two strings are parallel to each other, right? So theta is actually 0. For this one, it depends on the question. You will get, if you have alpha as 30, in that case angle will be 60. So you need to that value depends on this given angle. Similarly for this setup, 30 60, so you just subtract this thing from 180. It can be 60. So it depends on the given value. You just calculate the angle between the two string, that's your theta. Okay, angle between the two string is the theta. So this is a generalized formula. You can actually substitute 90 and simplify it, substitute 0 and simplify it. If you substitute 0, you will get 2t like after simplifying, but I do not want to actually give individual formula for each setup. I prefer using the generalized formula. This is the general formula. You, for each setup, you find the theta. So substituting theta will give you the force. That's it. Okay, so for our situation, like this one, number 5 from student's book, for our situation theta is actually 90. So for part C, you just, you know the value for tension, right? For part B, so t square plus 2t square cos theta. So you just substitute t and theta. Theta is 90, t is the answer of part B. So when you substitute this thing, you will get the value for the force which is exerted on the pulley. Okay, so we have particle A, mass 5m, so weight is 5 mg. For B, it's 3m, so weight is 3 mg. Rough horizontal table 2 meter high. Okay, then particle A is 3 meter from the pulley, so distance between particle A and the pulley is 3. Coefficient of friction is 3 by 20, so that's mu. The system released from rest, so u0. We need to find the initial acceleration. So like I said, whatever the question is, you just draw the diagram, include the forces and form the equation. Very simple few steps. Okay, just include the forces first. So we have reaction force, tension will be towards right, frictional force will be towards left. So that's the forces for particle A. For B, we have only weight and tension, only this two, because it's hanging freely in the air, so we do not have any contact force, so no reaction force or frictional force. So it's similar to each and every single math is similar. You just draw the diagram and form the equation, that's it. So for particle B, I'm starting with particle B. It is going downward, so 3 mg positive, and then tension negative equals to 3 ma. So tension is basically 3 mg minus 3 ma. Okay, so and for particle A, it's towards right, so tension is positive. Mu r, mu is basically 3 by 20. 3 by 20 it's given, and r, if you consider the vertical direction, it's balanced, so r equals 5 mg. This math are lengthy, but the process is similar. So if you practice 3 or 4 maths like completely by yourself, then you will find it easy. 5 mg is your reaction force. So tension minus mu r, as in the frictional forces, equals ma. 3 by 4. So from here I am getting the second equation. So 3 by 4 mg plus 5 ma. Okay, so that's the two equation for particle A and particle B. We are solving part A, which carries 8 marks. Like you are finding equation, you will get 2 marks here. You are solving this to get the second equation, you are getting this. From the second part you are getting 2 marks, so already 4 marks. Next you just need to solve this and get the value for A. So 3 mg minus 3 ma, 3 by 4 mg plus 5 ma. If you just subject A, if you cancel out all the m, like factorize and take common and simplify it, you will get like 9 by 4g, 8a. So A is 9 by 32g. So that's part A, 9 by 32g. Then for B, you need to calculate the speed with which immediately B hits the ground, like the speed with which B hits the ground. That's what we need to calculate. Okay, So let me just remove this thing from here. So I'm working with B now. We need to find the velocity with which B hits the ground. That's part B. So initially B starts from rest, so U will be 0. U will be 0. A is 9/32. We calculated this, and distance is given 1. So V square U square 2AS. So from here, if you calculate it, it will be 2.35. So that's the velocity. Then comes the most difficult one. When B hits the ground, it comes to rest, string becomes slack. The concept I have already discussed in the last lecture. Like if both the particles are moving, the string will be tight, there will be tension, this acceleration will be applicable. But the moment this one of the particles stops moving, for example this case, B is going downward. When B is already getting 1 meter in this downward direction, by then A has already covered 1 meter, right, towards right. So A is here just when B hits the ground. But the point is, when B hits the ground and stops moving, that's when the string becomes loose and tension is no longer there. So the previous acceleration is not applicable anymore. So but then again, when B was moving with 2.35 while hitting the ground, A was also moving with the same speed, right? So A cannot just stop moving. It needs few seconds, it needs a certain amount of time to actually stop moving. So that's the moment of inertia, and within that time period it will already cover a distance. So I am trying to find this distance covered by particle A. Okay, so for this journey from this point to this point, U is this one. Like B was moving with the same speed with which A was moving, so U is 2.35. okay, because they are moving with the same speed. Always they are moving with the same speed and acceleration. Okay, so A will start moving with this, then it will slow down and comes to rest. So V is 0. But the thing is, what is the acceleration? Since you cannot use this one, besides it will not even accelerate, it will start decelerating because of the frictional forces. Okay, so you need to calculate the new value for A. Wait a minute. You need to calculate the value for A. So for that, what we do, we just that's the equation of particle A. So in this equation, wait, let me use the first line. So in this equation, we do not have any tension towards right, so tension will be 0, but frictional force which was acting towards left, that's constant, that's the same value we need to use. So in the motion of equation of motion for particle A, we are just substituting the value of T as 0 because tension is not there. The string is not taut anymore, it's slack, so that's why tension 0. So if you cancel out 5 m, so you will get minus 3/20 g. Okay, so V square U square 2A, A is negative because it is decelerating S. So if you simplify this thing, this will give you S equals 1.878. But we need to this is the distance moved by particle A in this time frame. Okay, but we need to calculate how far particle A is from the pulley when it comes to rest, like distance between particle A and the pulley. So this is the distance we need to calculate. So the thing we have calculated 1.87, that's here 1.878, and this distance is already 1. Like by the time B has moved 1 meter down in downward direction, A has already moved in the right side, right? So this is 1, this is 1.837. we need to find the remaining distance, how far particle A is from the pulley. So distance between particle A and the pulley, that's the distance we need to calculate. So total is 3. So if you deduct 1 and this one from 3, you will get the result. So distance is 3 minus 1 minus 1.878. So this will give you 0.122.